right, we are looking at some exponents today. So for 6-1, this is over just your basic use of exponents. And so I'm going to dive in a little bit deeper and hopefully give you some reminders of what it means when you're using exponents. So starting out with this first example, what we have is 3x squared y, then that's going to be squared. And so kind of what happens every time we have parentheses is that this 2 is going to get applied to every single part of this. And so first of all, let's think about what does it mean when we're squaring something. Well, it's kind of the same as when you're moving from, in third grade, you move from doing addition to multiplication. And so when you first started talking about multiplication, if I was doing 3 times 4, we'd say, well, what's 3 plus 3 plus 3 plus 3, add it over and over again, which would give us 12. And you start to kind of figure out that, well, multiplication, when I do 3 times 4, because you're adding 3 together 4 times, it gets you the same thing, to 12. Well, exponents are doing the same thing, just with multiplication. So when I do 3 squared, it's the same thing as saying, what is 3 times 3? And so when I do 3 times 3, that one with a number we can square out, and we would get a 9. Now let's look at this x squared. So when I have x squared, and just kind of pulling this out here, we're going to look at the x squared squared. So x squared itself is already x times x, same as 3 squared is 3 times 3, but we're going to multiply that times itself again. And so I'm doing x times x times x times x. And so I get x times x times x times x. Right? And so what this does is this gives me 4 of those x's, and so it's going to be now x to the 4th. And the problem with using 2's is kind of asking, well, wait, are we multiplying those together? Are we adding them together? Kind of what's going on here? So when we've got this raised to a power, you're actually going to be multiplying. So let's say if it was x to the 3rd power squared, then we're going to be doing x times x times x squared. And so when I multiply that by itself, it's x times x times x times x times x times x, which gives you 6 of them. So that kind of tells us, okay, we are multiplying. So anytime you have exponent, so exponent raised to a power, exponent raised to another exponent. So for example, x to the 3rd squared. We will multiply them and get whatever that is multiplied together. So anytime you've got exponent raised to another exponent, we are multiplying the exponents together. So that is how we got the x to the 4th there. When we do y squared, it's just going to be y squared. All right, looking at my next one, we've got negative 2 squared to the 3rd power. So remember on this, we're working our way outwards, and really we could multiply the exponents first, but a lot of times it might be easier if we apply that first. So remember, that would be doing -2 times -2, and this is one, if we put it in the calculator, you got a chance of getting it wrong, just because if you put in -2 squared without parentheses around it like this, it's going to give you a negative when it should be a +4. So make sure, if you're going to put it in the calculator, that you put parentheses there. That way it applies it correctly. Just multiplying it out, that would be a +4 to the third power. Should be 4 times 4 times 4. And that gets me 64. So make sure on those, if you're raising a negative to an even power, it's going to turn it positive, kind of the same as absolute value is doing. Anytime we have an absolute value, it'll turn positive. Anytime you raise something to an even power, it squares it and makes it positive. All right, looking at number 3. When we have two sets of exponents over one another, well, first let's look at 12 over -4. When I've got this fraction here, I can actually just divide that out and say, well, 12 divided by -4, that would be -3. Then when I look at a to the 7th over a to the 3rd, there's some canceling out that's going to happen there. So if we think of that as 2, 3, 4, 5, 6, 7 a's over 3, then those will cancel some of them out, and I'm left with just a to the 4th up there. And so what's happening here is we'll subtract. So we're really doing 7 minus 3 in those exponents to get a to the 4th. And so remember, when we have the exponents like this 4 is not applying to the -3, just to the a. And so that would be our answer for that one. All right, looking at what we've got next. I've got some term out here, xy squared. It's being multiplied by 3x squared plus 2y squared. So when I go to distribute this, it's going to be multiplying well, I've just got a 1 here, so let's go ahead and say that's just a 3. Then x times x squared. So again, think of that as we've got an x, and we're multiplying that times x squared, which is x times x. So all total here, we've got 3 x's being multiplied, so we'd say it's x to the 3rd. So for this, we're really just adding the exponents together. So when we have exponent times exponent, we're going to add. And then there's no y squared there, so we'll just tag that onto the end. Plus 2. There's no x, so we'll put that at the front. Y squared times y squared will give us y to the 4th, because we are adding those together. So since these are not like terms, they won't combine, but that gives us 2 terms, and it's simplified a little bit. Okay, next we have a fun rule, because what they'll do on this is they'll give you a full long equation and all this stuff to do, and then at the end you've got it raised to the 0 power. And so what you have is anything to the 0 power is just going to be equal to 1. So all of this, doesn't matter whether it combines or not, it's in parentheses, has a 0. We'll say it equals 1. So, great rule, because if you recognize it, it's going to move that along pretty quickly. On our next one, looking at it when it's 4 to the power of something, as long as the bases are the same, and we're multiplying, so same base, we're going to add exponents. Okay, so kind of the same here when we were distributing, we add exponents. And so what we're going to do is we're going to add that y plus 2 plus 6. So we can kind of combine it together and say 4 to the y plus 2 plus 6 power, which is just going to be 4 to the y plus 8 power. And so that when you've got that same base, kind of the same thing we were doing if we had x squared times x to the third, we'd add together those exponents because it's multiplying something together, similar to here when I've got 6x's multiplied by each other, it gets me x to the 6th, because we're adding one together 6 times to get that. So, same bases, we will add exponents together. Alright, if we've got a fraction to a certain power, we're still doing the same thing. We're still going to distribute that 2 to both of those. So, have a to the 4 times 2, which is 8, over b squared. And then that's going to be multiplied by, let's see, a squared to the third power. So both of those would be to the 6th. A to the 6th, b to the 6th. And so I end up with, now when I'm combining these, if it's a whole number, not a fraction, think of it as over 1, and we're going to combine that just with the top. So a to the 8th and a to the 6th is going to be a to the 14th, and I've still got b to the 6th. Then I've got b squared down here. And so remember, just like our canceling out up here with the a values, I've got b squared and b to the 6th. So we'll subtract those. Those cancel out, and this goes down to 4. So my final answer would be a to the 14th, b to the 4th power. And then one last one of this type. This, when I do all of this to the 3rd power, we're always going to look and see, can this simplify it all here? And so for this, it's already completely simplified, but we're going to distribute, because if we combine this with something else, what's going to happen is we'll have this times another fraction, something along those lines, or divided by another fraction like this, and so we'll end up being able to simplify kind of like that. So everything is going to be to the 3rd power. So 4 to the 3rd power would be 64, multiply x to the 6th, y to the 12th, and z to the 9th. Okay, just straight applying the exponent to every single thing. Okay, and then the last ones, when we solve, if we're solving for x in this type of format, well, we know we're just applying kind of the rule we did up here. It is the same base, so that means we add exponents together. So really, I'm getting rid of the 3's, and it would be x plus 2 equals 8. And so kind of the pattern is, if it's an raised to a power, that's going to take whatever operation we're doing down a level. So if we're multiplying these two together, we add exponents. If we have exponent to another exponent, we multiply the exponents together. And if we are if we were adding these together, we do nothing with the exponents because there's no level below addition. And so here, subtract 2 from both sides, we should get x equals 6, which makes sense because 3 to the 6th times 3 squared. Put those together, I'd get 3 to the 8th, and they'd both be equal. Similar thing going on here. I'm going to drop the 3's, and going down a level from division is just going to be subtraction. So it's going to be x minus 2 equals 10. So x should equal 12 when I subtract those. So 3 to the 12th over 3 squared. If I were to put those in the calculator, that would get me some big numbers that simplify out to be the same as what 3 to the 10th is. So a lot of this is review and a little bit of new stuff added onto it for starting out with your exponents and using your power rules.